What I have here is I graphed the two functions that were given, x squared plus 2x plus 1 and 2x plus 5. I graphed it on Desmos because my graphing calculator at home won't work on my Mac. And so to find the area between those two curves, your steps are the same on your graphing calculator. You enter both equations, then you calculate the intersection of the two equations. And so -2 is where it starts and +2 is where it ends. So to find the area between the two curves, you take the area of the top, which is 2x minus 5. That'd be everything underneath that line to the x-axis. And you subtract the area of the bottom, which is everything that's underneath. So we're left with just the area between those two. So if you were doing this by hand, you would integrate this function, and that would be your answer. I have here the second problem on the page. Again, graph both functions. Use your calculator or Desmos if you're using a computer. And we need to find out where the graphs intersect. And so you can do calculate intersection, or if you had to do this by hand, you'd set them equal to each other and factor. And so we find out they intersect at 0 and 3. So all we need to know is which function is the top function and which is the bottom. And to find the area between, you take the top function, which would give you the area all the way to the x-axis, then the bottom function, which would give you the area to the x-axis there, and then we'll cut it out. Remember, anything under the x-axis is going to be negative, so this little negative area is going to be subtracting the opposite, so it'll become positive. So we're just left with that inside part. And I did a little integral here. You get 9, but this is one you could do by hand. Pretty easy polynomial function as well. This problem includes some functions you won't be able to graph on your calculator unless you turn your calculator sideways. If you think about this graph as -x squared plus 2y, it would be a parabola. You can show that y equals -x squared plus 2y. You'll see it's the same parabola, it's just turned sideways. So you could turn your calculator to the left 90 degrees and you have the same graph. And then y equals -x, and that's the same thing. But I want to get rid of those so that you can see this is what the graph, and so you can do this algebraically. You set them equal to each other and you still find where they intersect, only this time you're looking for the y. And so to find the integral, it's still the top function minus the bottom function. This is like a negative parabola, so upside down. And you can find a couple points and test until you figure out which one is above and below. We'll work on some techniques there, but the parabola is above, so we're taking that one. So we go right to left. But if you turn your calculator, it would just be top to bottom there. Same exact graph as if it were turned sideways. So turning your calculator is a way you can help figure it out, and use the algebra and your integral. You get 4.5. You integrate this same way as you integrate anything with x. It's just with respect to y, and we'll be doing some things with respect to y as we get into area and volume.